Mathematics course, Chapter 1, Functions, and this is the second part of this chapter. We begin this part by defining function composition. Function composition is a way to find a new function from old one. So, if you have, for example, two functions, f and g, we would like to define the composition of these two functions. As I said, it is a new function, h, defined this way. H of x as a function equals fg of x. Note that we apply g first on x, then we apply f. This new function, which is called the composition function, is always written this way, f circle g. Or we say h of x equals f circle g of x. This is the notation for the composition function. Again, to explain composition of two functions, consider it as a machine where you start by x. It's like the input in that machine. Then you apply first g to get g of x. Apply g on x, you get g of x. Next, you apply f on g of x, so you get f g of x, and that is the output. This is actually the composition of two functions, which is written f circle g. Again, note that when we write f circle g, we apply g first. We apply the function g first. Let us take an example and consider the given two functions. We have two functions here, f of x equals 3x plus 6, g of x equals x squared minus 1. Two requirements. The first one, find fg of 1. Fg of 1, that means the composition function when x equals 1. We apply g first. So g of 1, what is g of 1? G of 1 means put x equals 1 in g. When you put x equals 1 here, g of 1 will be 0. When you get g of 1, which is 0, put it 0 here. So find f of 0. Find f of 0. So this is the solution. G of 1 is 1 squared minus 1, which is 0. So it will become f of 0. Now to find f of 0, put x equals 0 here. It will be 6. So the requirement fg of 1 is equal to 6. The second question, we need to find the general form of the composition function f circle g. The composition function f circle g, we know that it is equal to f g of x. Here, we know this formula, f g of x. I will look at this one as it is the function f. The function f of g of x. What is the function f? Here, look here. What is f of x? It is 3x plus 6. What is f of y? 3y plus 6. What is f of z? 3z plus 6. What is f of r? 3r plus 6. So here, if you want to find f of g of x, so it will be 3g of x plus 6. So by using the formula of f, we can write that. Substitute for the formula of g of x in here. In the next step, we know what is g of x. G of x is equal to x squared minus 1. So replace g of x by x squared minus 1. So it will be 3x squared minus 1 plus 6. Simplify, you will get the composition function f circle g. How about if we wanted to find g circle f? So that is the third requirement here. Find g circle f. Note that in the second requirement, it was f circle g. So we apply f first. We apply here f first. So this is the formula. G circle f is equal to g f of x. Now, How can you find the g f of x? I will look at the function g. What is the function g? G of x equals x squared minus 1. G of y, what is g of y? G of y equals y squared minus 1. G of z equals z squared minus 1. So what is the g of f of x? G of f of x will be f of x squared minus 1. Now you use the formula for f of x. I know that f of x equals 3x plus 6. So I will put here 3x plus 6. You expand this, you multiply 3x plus 6 times itself, then subtract minus 1 and summarize it to get as an application on functions. Consider this example, which is about drug dosage. If the recommended adult dosage for a drug is D in milligram, then to determine the appropriate dosage C, so C is the dosage for what? For a child of age A. So A is the age of the child. Pharmacists use the following equation. C equals 0.0417 D times A plus 1. Now, what is A? It is the age of the child. What is D? D is the adult dosage. And what is C? It is the dosage, the recommended dosage for that child of age A. So this is given. Suppose that the dosage for an adult is 200. That means this is D. D is 200. Okay, that's given. It is, of course, it differs. D here differs from a drug to another drug. Some questions. Find the slope of the graph. If you look at this graph of this function, if you look at this function, by the way, this is a linear function. This is a linear function. We need to find the slope of the graph of C, which is a straight line, and explain what does it represent, what does the slope represent. This is the first question. The second question, what is the dosage for a newborn? For a newborn baby. For a newborn means what? Means the age is 0, means A is equal to 0. So to answer question A, we first knew that D is 200. So substitute here for the formula for C, the given formula for C, for the value for D, the given value for D, which is 200. So multiply this times 200, then times A plus 1, you will get this formula. So C equals 8.34 A plus 8.34. This is actually C here, which is the dosage for a child with an age A. This is a linear function, which represents a straight line, or its graph is a straight line. What is the slope here? This looks like y equals ax or mx plus b. So this is the slope. This is the slope. The coefficient of a here is the slope. So the slope of this straight line is 8.34. What does it represent? What does that slope represent? It represents the change in milligram of the dosage for what? For a child. For each change in 1 year in age. When the age changes 1 year, the dosage will change this amount. So the slope of a straight line here has a special meaning in our problem. For the second part, we need to find the dosage, which is C, for a newborn. For a newborn, as I said, A should be 0. So put A equals 0 in this equation, in this linear function. when you put when you put A equals 0, you will get C equals 8.34 milligram. So this is supposed to be the dosage for a newborn. Another application of functions, which is the exponential growth and decay function. Exponential growth and decay function. If you do remember the graph of the exponential function, the exponential function is an increasing function. It is going up this way if the power is positive, and it is going down, which means it is decreasing if the power is negative. So that's why this function, we call it exponential function, and if it is increasing, then we call it growth, and if it is decreasing, we call it decay. So again, this function y equals y naught e to the power kt. This is called exponential growth and decay function. If the power of e is positive, it is a growth function. If the power of e is negative, it is a decay function. What is y naught? Y naught is the amount or quantity or the number of the population, for example, present at time t equals 0. So y naught here, it's like y0. That means that the amount at time 0, the amount at the beginning, the initial amount. And what is y? Y is the quantity at time t. The quantity is said to grow or decay exponentially if for some constant k, the amount present, which is y, at time t is given by this equation. So y is the amount at time t. Y naught is the amount at time t equals 0. What is t? T is the time. K is a constant. If k is positive, we have a growth function. If k is negative, we have a decay function. Sometimes we don't use y and y naught. We use b of t, the amount at time t, equals b of 0. Instead of y naught, we use b of 0, the amount at time t equals 0. Some other times we use q for quantity. So q of t, the quantity at time t, equals q of 0, the quantity at time t equals 0, times e to the power kt. So this is the formula for exponential growth and decay function. We can use any one of these three or any other notation if you want, and that of course depends on the type of problems you are discussing. Let us take an example. Find the growth function. Find the growth function, that means y equals y naught e to the power kt. This is the growth function. We call it growth function if k is positive. If I said find the decay function, it is the same function. Y equals y naught plus k plus e to the power kt, but k in that case will be negative. So find the growth function if 5 grams grows exponentially. 5 grams growth exponentially, so this is the beginning amount. This is the beginning amount. We're starting by this amount, 5 grams. 5 grams, okay? So this is y naught. And it grows exponentially. Grows exponentially, that means we are using the exponential function e, the natural exponential function e. It grows exponentially to what? To 18 grams at 16 hours. When the time t is 16, this will be the amount. So this is actually y when t equals 16. We need to find the function. So to find the function, as I said, this is the function. Y equals y naught e to the power kt. Two unknowns here, y naught and k. we have two things we don't know them, y naught and k. But y naught is the amount that is present at the beginning. We know that. The amount at the beginning, at t equals 0, is 5 grams. So this is the y naught. Again, y naught is the amount present at time t equals 0. So it is 5, as it is given in here. The second given is what? We know that y is 18, the amount is 18, when the time is 16. We use this information to find k. We use this information to find k. So now put y equals 18, y naught equals 5, and t equals 16. Substitute t equals 16. What is unknown here? It is k. So we use this equation to find the constant k, which is actually sometimes we call it growth constant. Growth constant. If it is positive, you have growth. If it is negative somehow, okay, then we call it decay constant. Now, to find k, we take len of both sides. So now take natural logarithms on both sides. And of course, we will use the rules for logarithms, and also we will use the fact that len e equals 1. We have seen these rules in the first part of this lecture. So let's find k. Let us find k. We have this one, and we said we are going to take len of each side. For the right side, you have len of a product. What is len of a product? It will be len 5, len first, plus len of the second, e to the power 16k. For the second here, you have a power 16k. One of the rules is that you can take this power down here. So you take 16k. What will remain here? It will remain len e. And what is len e? We know that len e is equal to 1. So it will be removed. So we don't have anything here. Now, take len 5 to the left side, divide by 16, you can get k. Use your calculator to find an approximate value for k, and substitute in the formula. You will get the growth function, the required growth function. You have y naught and you have k now. This is the required exponential growth function. Another example. Let us consider a bacterial culture. You have a certain bacterial culture, okay, which contains 100 cells. We have a bacterial culture which contains 100 cells. So 100 cells, this is the present amount of cells. So this is at the beginning. So this looks like y naught. This looks at the number that is present at the beginning. When the culture is checked 60 minutes later, that means at time t equals 60, it is determined that there are 450 cells. So this is the number of cells present when the time t equals 60. Assuming exponential growth, when we assume that we have exponential growth, that means you have the formula y equals y naught e to the power kt. Or you can use the formula for a number like b of t equals b of 0 e to the power kt. Now, what is the question? Determine the number of cells present at any time. Determine the number of cells present at any time. If we are going to use the formula where we have the notation for b, so that means we need to find b of t. We need to find b of t. But we have another requirement here, and find the doubling time. What do you mean doubling time? It is the time when the number of cells present doubles. So we will use this formula, b of t equals B of 0 e to the power kt. B of t, the number of cells at time t, at any time t. B of 0, the number of cells at time 0, at the beginning. At the beginning, we know that we have 100 cells. So this is B of 0. So put B of 0 here. Next, we need to find K. So we use the second observation to determine K. What is the second observation? The second observation said what? We have 450 cells at time t equals 60. So B of 60, the number of cells when t equals 60 is 450. 450, and you put t equals 60 here. So 450 equals 100 e to the power 60k. This is an equation, and you have one unknown, which is k. Again, how can we find k? You take len of each side. Take len of each side to find k, as we did in the previous example. Thus, you will find an approximate value of k, which will be that value. You have now P of 0 and K, so you can write down the formula for the number of cells at any time t. So this is the formula that represents the number of cells present at any time t. That is the first requirement for this problem. But there is another one. What is it? We need to find the doubling time. What is the doubling time? It is the time it takes for the number of cells to double. The time it takes for the number of cells to double, that means the number of cells should be 200, as we have at the beginning 100 cells. So we need to find t, the time t, when the amount B of t is 200. Substitute now in the formula that we got in the first requirement. This one, 200 equals B of t, and we have k here. How can we find t? To find t, you take len of each side. Take len of both sides, and approximately you will get t equals 27.65. This is in minutes. So that means the doubling time for this culture of bacteria is about 28 minutes. So that means every 28 minutes, the number of cells present in this culture of bacteria will be doubled.